what we call the density. So what's density, class? Density is it a constant value for a substance? No? I mean, does all substance have the same density? I mean, for each substance, they have their own density. It's an identity. Because density is an intensive property. Am I right? Mean to say, regardless of how much of its substance you're going to get, the density remains constant. But here's the thing. Density, class, is always measured at a certain temperature. Because if you're going to look at the formula for density, density is mass over volume. So if we say that this particular property is constant at a certain temperature. Because like I said, if volume is involved, that's highly temperature dependent because solutions or matter expands when heated. Do you follow? So that is why, for example, what's the density of water? What's the density of water? 1 grams per ml. Am I right? Yeah. But that is not true all the time. It's true for a certain temperature. Do you follow? Is that clear? Alright. So density, class, may be expressed as either kilograms per liter or milligrams per, grams per ml. So they could not be interchanged. So the density of water, therefore, can be expressed as 1 kilogram per liter, or it could also be expressed as 1 grams per ml. Is that clear? That's how you interpret the density value. Now, how about its specific gravity? Specific gravity, class, is simply the ratio between the density of the substance and the density of water at 4 degrees Celsius. You follow? So again, specific gravity is what's specific gravity? Density of substance over density of water at 4 degrees Celsius. Okay, that's your specific gravity. What's the density of water at 4 degrees Celsius? It happens to be 1. So whatever is the specific gravity is equal to the density of the substance without the unit. You follow? Why without the unit? Because the unit of density here and the unit of the density here will cancel out. You follow? For some reasons, they are actually, trying to express values in specific gravity. Like I said, it's just equal to, again, a value of the density. Do you follow? So why do we need density, class? Density is used when converting mass to volume. Do you follow? So here are some conversion factors you need to remember. So when converting mass to moles or vice versa, you'd have to use the molar mass. Do you follow? But if you're converting mass to volume, then that requires for you to use density. So when is that important? Okay, for example, you are given this problem. Calculate, which is also the problem that you need to solve later in the lab. Am I right? Sige. Supposing you are given a molar, you are to calculate for the molarity of nitric acid. The molar mass is already provided in a solution that has a specific gravity of 1.42 and is 70.5% nitric acid by weight. Okay. When is specific gravity and density going to be used? When are they going to be used, class? They're going to be used when you're dealing with converting weight percent to molarity. Diba? Weight percent to molarity. So if the problem asks you of that, then that would tell you automatically that I would have to use a density problem. Do you follow? Because the reason for that, class, is remember, weight is mass per mass. Am I right? match. Because in weight percent, the denominator is in terms of mass. But in molarity, it's in terms of volume. So it will require you to use density to convert this to NP. You follow? And this is often the case when you're dealing with solutions in the lab. Because like I said, if a chemical that is pure in the lab is liquid, it is often expressed as weight percent. Do you follow? But we are required to, prepare a solution in specific molarity out of it. You get it? So therefore, there's a necessity all the time to convert this weight percent into molarity. Do you follow? So how do we do this now? Okay, supposing you have this particular problem, okay? So you always begin with a given so that you won't get lost in translation. Do you follow? So what are given in this problem? First, you are given the fact that, well, the molar mass of nitric acid happens to be what? 63.0 grams per mole. You follow? This also means that as a conversion factor, 1 mole nitric acid, am I right, is equal to 63 grams nitric acid. Am I making sense? That's given. But if you don't know it, then you have to calculate. Do you follow? If it's not provided. And then what else are given? You are given the PGR, or the specific gravity of nitric acid. As you can see, there is no unit there because it is in ratio to the density of water at 4 degrees Celsius. Am I making sense? And what's the value there? The value is 1.42. But like I said, specific gravity is just equal to the density of the substance. Do you follow? So if this is equal to the density of the substance, what does it mean? What's the density of your nitric acid then? So the density is 1.42. And what's the unit? Grams per ml. Do you follow? Am I making sense? Am I making sense, everyone? So as a conversion factor, it could be used as conversion factor. This means that 1.42 grams nitric acid is equivalent to 1 ml nitric acid. Do you get it? Am I making sense, everyone? And what else is given? You are given 70.5 weight percent nitric acid. And what does it mean again? What did I tell you about weight percent? What did I tell you about weight percent? How do we interpret weight percent? Weight percent is actually, how do you determine this? 70.5 grams nitric acid, am I right? And what should be the numerator, denominator? Should be, mass over mass with the same volume. So if we have 70.5%, it's going to be divided by 100 grams of the solution. You follow? You follow? So we could set it up now. And what are we asking for? What are we asking for is moles nitric acid, am I right, per liter of your solution. But you are given this value over here. Am I making sense? You are given this value and it has all the problems in the world. Why? Because the numerator is in grams, which you want it to become moles. Do you follow? And the denominator is in grams, which you want it to become in liters. Am I right? But using this conversion factor, that would be difficult. Do you follow? That would be a difficulty. Am I making sense? So how do we solve for this then? So you try to solve by what? Again, doing dimensional analysis. Okay? You start with the mass here. It's going to be 70.5 grams nitric acid. You follow? And then what's other given? You are given that it contains 100 grams solution. Am I making sense? So you divide and conquer. You begin with the numerator. Am I right? So, what do I want for my numerator? Moles. Therefore, how do I convert grams to moles of nitric acid? How do I convert grams to mole? I use the molar mass. Okay? So what's the molar mass again? This is my conversion factor over here. Am I making sense? So in that case, what's going to be my desired mole? So I will place 1 mole nitric acid here. You follow? While placing 63 grams nitric acid there. So when I do that, ladies and gentlemen, what I'm achieving is I'm canceling my grams nitric acid. Am I making sense? I'm canceling my grams nitric acid. So I'm left with moles. So I will deal with it later. I don't have to solve it for now. I just want to set up the dimensional analysis that will give me my desired unit. Am I making sense? And then I go into the denominator. I am given with grams, but what am I looking for? Liters. Do you follow? So how do I do that? I use now my density. And my density is in terms of grams per ml. So I could use that. I could convert this into an ml, correct? Using density. Am I making sense? So how do I do that then? How do I do that is I multiply this with, for example, desired over given. What is desired? What is desired? I am desiring ml, correct? So I will place 1 ml there, and then what is given is 1.42 grams. And what do I have here? I will cancel out my grams, giving me ml. But what's the volume that I need? Do I need ml or liter? Liter. So therefore, there's a necessity to do another dimensional analysis that will convert ml to liter. And I know now that 1 liter is 1,000 ml. So therefore, I will place the 1,000 ml here and the 1 liter there. Am I making sense? And then we cancel out L, leaving me behind my liters. You follow it? So I solve them individually. Okay? 70.5 divided by 63. What's that? 70.5 divided by 63. 1 1.12. 1.12. What's the unit here? Mole nitric acid. Do you follow? Why? See the cancellation of units? Do you follow? So we already achieved the unit we desired for the numerator, isn't it? And then divided by what should be the so 100 divided by 1.42 divided by 1,000.
0.07.
So 100 divided by 1.42 divided by 1,000.
0.07.
Ilan?
0.07.
0.07 like that?
Yes, sir.
And it's going to be already in liter, which is what I desired. So divide this to 60. This is going to be total 60 molar.
16.
Are you following?
16.
Am I making sense, everyone? So therefore, nitric acid that contains 70.5% is equivalent to 16 molars. Am I making sense? Okay, questions? So in the laboratory class later, you are to prepare HCl, am I right? You will not be provided the molarity of HCl. HCl. But you are provided that your HCl contains 37 weight percent. So from that, you will have to calculate what's the molarity of 37 weight percent HCl. Am I making sense? Okay. Questions? Okay. On Friday, we will have a long exam for laboratory, but at the same time, we will also have a quiz for lecture on solution calculation. So it's not going to be open notes anymore, so it's a quiz. Okay?